Boys and girls, this is lesson 22 of module 3. What we're going to do today is find factor pairs to 100, and we're going to use understanding of factors to determine whether a number is prime or composite. Let's look at our application problem. 8 times some number is 96. So I did draw an area model. I broke 96 down to 80 and 16 because 8 tenths is the most that I was able to take out, and that left me with 16. 80 divided by 8 is 10. 16 divided by 8 is 2. You'll notice that I did it in a different model. I don't really want to call this a number bond because I did put the division in it. 96 divided by 8 breaks down into 80 divided by 8, which is 10. 16 divided by 8, which is 2. 10 plus 2 is 12. So our missing factor is 12. 8 times 12 gives us 96. Okay, in the first problem, we're going to identify factors and products that are represented in each array. If we look at our first array and count 1, 2, 3, 4, 5, 6, 7, 8. 1 times 8 is 8. 1 is a factor, 8 is the factor. The product or the answer to a multiplication problem is called the product. Let's look at this one. We have 1, 2, 3, 4, and then our second row we have 1, 2, 3, 4. 2 times 4 is 8. 2 is a factor of 8. 4 is a factor of 8. 8 is the product. All right, let's look down here. We have some different arrays. We have right here, we have 18. The sentence that would go with this is 1 times 18 is 18. If we look at this one, we have 2 rows of 9. The multiplication sentence that would go with this is 2 times 9 is 18. Is there another array that we can draw to represent 18? Yes, there is. 3 times 6 is also 18. All of the factors of 18 are listed here. 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. Notice how I have listed them in order, and I drew a little arrow kind of curved line to match them up to make sure I had them all. Now we're going to determine whether numbers are prime or composite. So just to review, if we have a multiplication equation, and makes it an equation because it has an equal sign, let's review factor and product. 2 and 8 are factors of 16. Now, are there other multiplication sentences that will give us the same product of 16? Yes, there are. 1 times 16 is 16. 4 times 4 is 16. If I were to list the factors of 16, I would say 1 times 16, 2 times 8, and 4 times 4. I do not have to write 4 2 times. Writing it once is enough. However, if you need to write it down twice, that's absolutely fine. Let's look at another multiplication equation. 1 times 7 is 7. What are other factor pairs to give us a product of 7? Now, if you were to say 7 times 1, you still are giving me the factors 1 and 7. Switching these doesn't give us different factors, so please keep that in mind. Okay, there are no more factors of 7. 7 has 2 factors, 7 and 1. Now, a number that has only 2 factors is called a prime number. Here are some other examples of prime numbers. 3, 5, 7, 11, 13, 17, 2. These numbers only have two factors, the number itself and 1. And there are many, 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 many more prime numbers. Those are just some examples so that you have some. Now, numbers that are not prime are composite. They're numbers with more than two factors. For example, 4 has more than two factors. 1 times 4, 2 times 2. 6 has more than two factors. 1 times 6, 2 times 3. 8 has more than two factors. 1 times 8, 2 times 4. 9 has more than two factors. 1 times 9, 3 times 3. I'm sure you see what I mean by more than two factors. It is very helpful for you to use your multiplication charts to help you with factors. In your assignment notebook, there's also a list called Factors and Products. It gives you the number, and then it gives you all of the factors and products for each. So it's very helpful when you're learning about prime and composite numbers. Okay, now we're going to determine whether or not a number is prime or composite. I like to draw a T-chart. This has worked really well in the past. And I'll show you how to use it. Alright, I put my number at the top, 23. I start off with counting. Okay, 1. Well, 1 is a factor of 23. 1 times 23 is 23. Is 2 times something 23? No. 3 times something 23? No. 4? No. 5? No. 6? No. 7? No. 8? No. 9? No. 10? No. 11? No. 12? No. Well, 12 times 2 is 24. That gets me past 23. And if I continue, there are no other factors of 23. 23 has exactly two factors. That makes it prime. 35. 1 times 35. Is 2 times something 35? No. Is 3 times something 35? No. Is 4 times something 35? No. Is 5 times something 35? Yes. 5 times 7 is 35. Is 6 times 7? Is 6 times something 35? No. Is 7 times something 35? Yes. 5. Notice. We're overlapping now. We have finished. So if we look, 35 has 1, 2, 3, 4 factors. That makes it composite. 48. Well, 1 times 48. Is 2 a factor of 48? Yes. 2 times 24 is 48. Is 3 a factor of 48? No. Is 4 a factor of 48? Yes, it is. 4 times 12 is 48. Is 5 a factor of 48? No. Is 6 a factor of 48? Yes. 6 times 8. Is 7 a factor of 48? No. Is 8 a factor of 48? Yes. Okay, we're now on to this finding numbers on this side, so we're repeating. So 48 is composite. 9. Let's list the factors. 1 times 9. 2. No, 2 times something is 9. 3. Yes, 3 times 3 is 9. Is 4 a factor of 9? No. Is 5 a factor of 9? No. Is 6 a factor of 9? No. 7? No. 8? 9. Okay, we're back to the other side. 9 has 3 different factors. 1, 9, and 3. That means it's composite. Let's look at the number 23. Factors of 23 are 1 and 23. Whoops, I didn't realize I did that twice. It's okay, because now we know we're finished, and it's prime. Let's look at 27. 1 and 27. Is 2 times something 27? No. Is 3 times 20 something 27? Yes. 3 times 9. Is 4 times something 27? No. Is 5 times something 27? No. Is 6 times 27 something? No. Is 7 times 7 times something 27? No. Is 8 times something 27? No. Is 9 times 9 times something 27? Yes. 3 times 9. So we're now on this side. We're starting to repeat. So there's 1, 2, 3, 4 factors. That means that 27 is the composite number.